So the z-score is going to take us into normal distribution. Also, it's called the bell-shaped curve. So this graphic, if you will, this curve has key characteristics that we'll be looking at. It has symmetry, and it's as it is bell-shaped, as I said. When it is got the symmetry, the mean, the median, and the mode are all at the same spot on the graph. Now, to define two parameters, we have mu, which is this Greek letter, stands for the population mean, but we're going to use x bar, which stands for the sample mean. Sigma stands for the population standard deviation, but we're going to be using S, which stands for the sample standard deviation. Also, if it's this bell-shaped curve, it follows what's called the empirical rule. So the empirical rule is a special little rule. It's the 68, 95, 99.7 rule. So if you want, you can pause the video at this spot and just kind of read through that data and make some notes down. I also got some tables and graphs that you can print out in this folder with respect to the empirical rule. So what this is saying is 68% of the data lies within plus or minus one standard deviation of the mean, so right or left of the mean. 95% of the data is going to be within plus or minus two standard deviations from the mean, and 99.7% of the data lies within plus or minus three standard deviations. So this is really good for our probability because that's where a lot of probability is going to be coming from, is this normal curve. So this bell-shaped curve, notice how this 64%, notice how 34% is to the right of the mean, 34% is to the left of the mean. So notice how the mean is right here in the middle. So this is where your mean goes. And then you can add your standard deviations and create other regions. So what they're saying is if you go one standard deviation to the left and one standard deviation to the right, 68% of your information should be within this category. Now, if we go out two standard deviations, this brings us into this next category, which is 95% is going to be within two standard deviations. Usually, if you go out past two standard deviations, this is where it starts to become an unusual event at this point. There's not much data that's out past these regions. But if you do go out to three standard deviations and notice how you're almost to the very end, and a lot of times, like I said, this is actually graphically, this is the x-axis, if you will. And then we have the area of the curve here. The area of the curve, notice how the area of the curve is going to be percentages. So if we're within three standard deviations, notice that 99.7% of the data, which means almost all of it, is within standard deviations. So if you're out past three, that is very unlikely of an event. Now, we can standardize this thing. So if we standardize it, what happens is the mean turns into a zero, and then as we move to the right and left of zero, that's our standard deviations. So we can create a standard normal curve where notice how the mean actually turns into a zero, and then we have one, two, three. When we do this, this is now the this actually now is going to be our z-score. So the x-axis actually now becomes our z. So this now would represent our z values. We're up here, we're still talking the actual values of the data. This is the actual mean of the data. This is the actual standard deviation of the data, but we can standardize it where using this formula, I can create z-scores, this x minus x bar divided by s. So remember, x is the data item. If we subtract the mean from that and divide it by the sample standard deviation, this creates a z-score. And what happens is this can now become a table. So zero now becomes the mean, one, two, three become our standard deviations, -1, -2, -3. So this looks a little bit prettier in that sense. So again, in your homework, you're going to be seeing applications involving normal distribution. So you'll probably see stuff with IQ scores, measurement errors, heights and weights, testing again, quality control, and just decision-making models as well. So again, one of the things that we'll pick up on is this z-score is going directly to correspond to a percentile in the normal distribution, as we were talking about. The empirical rule is going to help us on some of the common or rare. It's going to interpret how common or rare the value is. So extreme z-scores, like we were saying, are usually out past two standard deviations. Usually we call these unusual observations if you go out past that two standard deviations. So I believe that's all we really have to say here in this. I think we're just repeating ourselves here. So that's going to be the main two things in our homework is z-scores and how to tie that into one of the most powerful tools is our bell-shaped curve.